Okay, for number one here, we've got trying to estimate with a number line Jane and Marissa's cakes and with how much sugar they need. So if we start here with Jana's cake, and Jana's needs, let's see, she needs 1 2/3 cups. So if I have here, I'm going to do an estimate. Here's 0 to 1, and that's 1 whole. So she does need 1 whole cup of sugar, but she also needs 2/3. So we're going to do the same thing here, 0 and 1, and 2/3 is going to be right about there. So this is about how much sugar she needs in addition to this here. Now, Marissa needs 3/4 cup of sugar. So we're going to do the same kind of number line, 1, and then she needs, though, 3/4, which is about there. So we're going to estimate now about how much sugar do they both need together. So when we're looking at this, I can see that we automatically need 1 whole, at least 1. But then we've got here 2/3 and here 3/4. Now I can see that 2/3 plus the 3/4 is going to be more than 1 whole, but not quite 2 wholes. So my estimate for how much sugar the two of them are going to need is going to be somewhere between 2 and 3 cups of sugar together. Okay, so now we're going to do this problem using fraction strips. And what we're going to do is we're going to be adding together. We want to add the sugar that Jana needs plus the sugar that Marissa needs. So Jana needs 1 2/3 cup. So we're going to do 1 2/3 cup. And Marissa needs 3/4. All right. So we've got our things here. Okay. So now what we're going to do is we're going to add these together, but they don't have the same denominator. So what we want to do now is figure out what is our lowest common denominator here. And we can do 12ths. So I know this. So what we're going to do is we can say that this is going to be the same as, and these are not quite cut to par, but we've got our 3/4. 2/3 is going to be equal to 1 8/12. Okay, so I've got, this is the same as 1 8/12 plus, now we just want to figure out what we got here. So we have 1 and 2, 3/12 here, 3/12 over here, and then 3/12 here. All right. Now we need 1 more. Alrighty. So now we can see that 3/4 is going to be the same as 1 2 3 4 5 6 7 8 9/12. And now we've got this equals the same thing, and we can actually count these up now, and we're going to say that we know that this is going to be 1. Our answer is going to be 1 and 17/12. All right, we can even make this a little bit more because we know that 17/12 is going to be another whole. I'm going to change that to 1 and 5/12. If we add that to this 1, we get 2 and 5/12 cups of sugar that both Marissa and Jana need to make their cakes. Now we want to do the same problem using our circles. So we're going to use our circle models for this one, and we're going to add again. We've got Jana, who needs 1 and 2/3 cup of sugar. And we have Marissa, who needs 3/4 cup of sugar. Alrighty, so what we're going to do is we're going to see here now as we are doing this. Again, we can't quite add 3/4 plus 2/3. They're different sizes. It's like apples and oranges. We've got to make them all apples or all oranges. So we are going to, again, use our 12ths to make this make sense. So now we can stay up here, and we've got 1 and 2, 3, 4. I'm going to try to get those so you can visually see that they actually go in together. Yeah, there we go. And then we've got another 1 and 2, 3, 4. All right, so we've got our 1, 2, 3. So we can see again, we've got 1 and 2/3 is the same as 1, and we've got 1, 2, 3, 4, 5, 6, 7, 8 12ths. All right, so we've got that, and now we can figure out our 4ths. So what is going to be 3/4 equal to? So 3/4, we've got 1 and 2, 3, and these are not exactly to size, but they are numerically correct. So we've got 1, 2, 3, 1, 2, 3, and then 1, 2, and 3. Okay, so now we're going to add these, and we have our 3/4 is going to be the same as 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/12. All right, so now we want to add our numbers here. So we have, let's add them up. So we have 1 and 17/12. But we're going to fix that. So what we're going to do is, because I know that this is higher than this, so I want to figure out how to make it so that I can, how many holes are in here. So what we're going to do is, we've got 17/12. So if I count my 12ths first, so let's see here, we're going to make this hole here, hopefully. So we have 1, 2, 3, 4, 5, 6, and then we have 7, 8, 9, 10 is coming. They're a little bit hard to pull off of this mat here. 10, and then 11, 12. Okay, so now we have our hole here. So that is one hole. So we had one hole, and then we used 12 of them. And how many are going to be left? Because we need to add up to 17. So we've got 12 is another hole. So now we have 2 and then some amount of 12ths that are left. So let's see here. We've got, that's 12 here. So now we want 12, 13, 14, 15, 16, and 17. So how many 12ths do I have left? I have 1, 2, 3, 4, 5. 5/12. So the total amount of sugar that both Marissa and Jana need are 2 and 5/12 cup of sugar. Okay, so now let's take a look at both of these here, the circles and the fraction strips, and see if we can't figure out, let's compare it a little bit. And what was the same about it and what was a little different? So in both of these, in the circles, you needed to know that you needed to make a hole. So when we did this, you could tell that 2/3, you could physically see that that is 2/3 of a hole. You could see that happening there. And we were able to compare it into the 12ths. Now, both with the fraction strips and with the circles, you needed to know that both of those had a common denominator of 12. So you needed to be able to figure that out in order to make this problem successful. Now, the difference here with the fraction strips, these fraction strips, you could line them up and you could see the differences. Move that up a little bit so you can see it. And you could see here we have our thirds, and you could kind of get a feel for where things were going to fall. You could do a little bit of, you could estimate better, I think, with the circle fractions, the circles. But with the fraction strips, it was easy as well because you could compare it to the strip. Now, it's similar because you needed to be able to know that these little 12ths and how many you needed. For example, you needed to be able to fill this in, and if you had super purchased fractions, they would be way better than these, but you would be able to fit in there 3/12 into that 1/4. And then we could add those 3, 3, and 3. And the same thing here with the fourths. Here, you needed to be able to fit in 3 of these guys in there. So on both of these, it was the same thing fitting in order to make the denominator the same so that you could add it. But it was a little different in how you put that application into practice. These you had just the strips, and these you actually had like pie pieces. So it kind of depends on what visually you like better to use. Some people like the pies because they like to pretend that they're eating cookies or pizza, and some people like the strips because you can think about chocolate bars and 2/3 of a Hershey's bar, or 1/4 of a Hershey's bar, or 3/4 of a Hershey's bar for that matter. But in either case, these both give you an accurate representation and help you to compare the sizes together so that you could see even that 1/4 is less than 1/3. Now, sometimes students might mix this up a little bit, and you might instantly be thinking, well, I'm just going to add this up like this. Let me get all of this out of the way. I'm just going to use the fraction strips for some errors that we might see. So that might be like, okay, I'm going to add my 1 whole. I know that Elena needs that, and I might say, well, I mean, why do I keep saying Elena? I have a friend with a little girl named Elena, and I keep mixing up Elena and Jana. So Jana needs 1 2/3, and another mistake that might happen is I might not even be thinking, and I might just add this up like this, and I might just go, okay, well, that's 2 1/4, because I'm kind of mixing up how much I need here. Another mistake that could be another misconception that might happen is just straight up mixing up the denominators and the numerators. So maybe somebody might see this 1 2/3 and also 3/4. And they might just go ahead and add this whole thing up and say 1 5/7, which is just having to go back and really focus back on what are the skills that we need to do, and that we're always having a common denominator here. And that just needs to be stressed from the beginning, and lots of practice for that will help a student understand that this has to be the same whenever we're adding or subtracting.